All right, now we're into the 7th chapter of the 5th unit for Financial Math 1, and it's driving data. Today we're going to write, interpret, and use the distance formula, and we're going to use the formula for the relationship between distance, fuel, economy, and gas usage. So let's get started with example 1. It says a car travels at an average rate of speed of 50 miles per hour for 6 hours. How far will this car travel? So it's key here, it says it goes 50 miles each hour. And it's going for 6 hours. So we're going to take the 50 and we're going to multiply it by the number of hours they traveled. And in a 6-hour period, they went 300 miles. Please press pause, solve this, come back when you're ready. All right, let's take a look at this. It says a car traveling at R miles per hour for M minutes. Write an algebraic expression for the distance traveled. Now, my guess is that some of you just quickly said RM and thought you were done. But that's actually not correct. We don't want to be doing that. If we look back at the previous example, it talked about how many hours they were traveling, and we're looking for the miles per hour here. So it's the rate, which is similar to the 50 miles that they were going in the first example, times the number of hours. So we need to convert our minutes to hours, and we do that by dividing our minutes by 60. And there's your answer. Example 2, it says Jack lives in New York. He'll be attending college in Atlanta, Georgia. The driving distance between the two cities is 883 miles. Jack knows that that the speed limit varies on the roads, that he will travel anywhere from 50 to 65 miles per hour, and he figures that he's going to average about 60 miles per hour on his trip. At this average rate, for how long will he be driving? Express your answer rounded to the nearest hour and the nearest minute. So the nearest tenth of an hour and a minute. So I know that I'm going 883 miles, and I'm going to go 60 miles for every one of those. So when I divide that, I end up with 14.7 hours. And that answers the first question where it says to the nearest tenth of an hour. But now it also needs to the nearest minute. So to get the nearest minute, we're going to take what's on the right side of our decimal here, that 0.7, and we're going to multiply it by 60. Now, can you think of why I would be multiplying it by 60? And if you thought to yourself, because there's 60 minutes in an hour, you would be correct. So 0.7 of an hour is actually 42 minutes. So to answer the second part of this question, it would be 14 hours and 42 minutes. All right, please press pause, solve this, come back when you're ready. All right, let's look at this. It says Danielle drove from Atlanta, Georgia to Denver. She drove between Atlanta and Denver, which is a distance of 1,401 miles. She averaged 58 miles per hour on her trip. How long is the driving time to the nearest minute? So hopefully your first step was you took 1,401 and you divided it by that average mile per hour, which was 58. And you got 24.155. Now, remembering from the last example, we've got to get it to the nearest minute, so we're going to take that 0.155 and we're going to multiply it by 60 to get how many minutes that was. And we find that it's 9.3 minutes. Now, it's asking us to round to the nearest minute, so our final answer here is 24 hours and 9 minutes. All right, example 3. Kate left Albany, New York, and traveled to Montreal, Quebec. The distance from Albany to the Canadian border was 176 miles. The distance from the Canadian border to Montreal, Quebec is approximately 65 kilometers. The entire trip took her about 3 3/4 hours. I'm going to rewrite that as 3.75 hours. Now, hopefully you went through and you did the reading and you looked at your vocabulary for here, because there's a few conversions that we need to know about. And the first conversion is we need to understand that there is 1 kilometer in 0.621371 miles. And in 1 mile, there is 1.60934 kilometers. So we can't really just add kilometers and miles together because they aren't the same thing. It would be like trying to add apples and oranges together. So what we need to do is we need to convert our kilometers to miles. So to do that, we look at our conversion, and I know that I have 65 kilometers, and I know that each kilometer is 0.621371 of a mile, so I'm going to multiply by that value, and I find that it is 40.389 miles. Now I can go ahead and add those together, so I'm looking at the 176 miles, plus I'm going to go ahead and round this to 40.4 miles, which gives me a total of 216.4 miles. I know that I took 3.75 hours for this trip. So my last step here is I'm going to take 216.4 and divide it by the 3.75, and I end up with 57.7 miles per hour. All right, please press pause, solve this, and come back when you're ready. Okay, it says in example 3 above, could Kate's kilometers per hour have been calculated by multiplying her miles per hour by the conversion factor? Explain your answer. And I'll tell you right away that absolutely we can do that. And what we're going to do is we're just going to do the conversion the other way. So it's 176 miles. And I know from my previous example that 1 mile equals 1.60934 kilometers. So when I multiply that out, that's 283.24 kilometers. When I add 65 kilometers to the 283.24, I end up with a total of 348.24 kilometers. I'm then going to take that 348.2 kilometers and divide it by the same time period, and I find that she was going 92.864 kilometers per hour. Now, just to show you that that is exactly the same as the previous example, I want you to take that 92.864 and I want you to multiply it by the conversion to go back to miles. And if you plug it into your calculator, you see that when you multiply those values together, you end up right back at 57.7 miles per hour. Example 4, it says that Juan has a hybrid car that averages 40 miles per gallon. His car has a 12-gallon tank. How far can he travel? Well, 12 gallons in a tank, 1 gallon is going to get him 40 miles. So 12 gallons, if I multiply that by 40, is going to get him 480 miles. Please press pause, solve this, come back when you're ready. All right, let's take a look at this. It says that Lily drove a total of 500 miles on G gallons of gas. Express the fuel economy measurement in miles per gallon as an algebraic expression. So I'm simply going to take my total miles and divide it by my gallons. And there we are. And that finishes this video. We'll finish the last two examples in the second video.